On this podcast, you'll find interviews with high-performing, successful individuals in life sciences. On a weekly basis, we cover their proven methods, principles, strategies, and mindsets to implement new technologies that scale to meet the needs of people in our world.
Today, I'd like to welcome to the podcast Dr. Oscar Segurado. He's an executive veteran of the biopharmaceutical industry with extensive global leadership experience in medical affairs, clinical development, and translational science. Currently, he's the Chief Medical Officer of ASC Therapeutics. He's been previously Vice President for Becton Dickinson and Global Medical Head for Abbott AbbVie Humira. He holds a tenured professorship of immunology at the University of Lyon, Spain. He received his PhD from the University of Würzburg, Germany, and an MD from the University of Salamanca, Spain. So today I'd like to welcome Oscar Segurado to the podcast. Welcome, Oscar.
Thank you so much. Great to be here.
Yeah, thank you so much for spending some time with me. First of all, we're going to spend a little bit of time today talking about CRISPR. I think the most exciting thing that just came across in the news is that Emmanuel Charpentier and Jennifer Doudna both won the Nobel Peace Prize for Chemistry. How exciting was that for you?
Extraordinarily exciting because although I don't know Jennifer personally, I've been working with several people that are in direct touch with her. And Berkeley is about less than 1 hour away from where we have our headquarters and where I live too. So it's something very close to my heart also.
That's great. And so I guess just to go a little bit further in terms of what they actually were noted for, right? So my understanding of Cas9 is that it is a way to use CRISPR to actually splice the DNA or cut it, and then you could either insert or delete. Is that correct?
Correct. This is kind of the cut and paste that we do with our computers when editing texts all the time. Everyone knows that DNA is just a kind of a combination of letters, and every 3 letters are able to put together an amino acid. When you combine all these amino acids, you create proteins, and those proteins lead to tissues, organs, and that's life. So we're going here into the origins of everything that makes us breathe and think. So what this group, or it was the French group working together remotely, I think that's a good thing nowadays to talk about, was to be able to start working on that in tissue cultures. And from there, other groups, and they themselves started to see how that could also translate into changing and editing and transforming the way we see our DNA and doing these kind of steps until going into proteins and so on. And we will talk about how that applies into actual biotechnology and medicine.
First of all, I really jumped into the topic, and I just would like to take one step back and just talk a little bit about you, who you are, and where you got your start, first of all.
As you can notice with my accent, I'm not Native American. I'm originally from Spain. And that's where I grew up, and I went to medical school, and I did some research, especially in the area of immunology. When you're an immunologist, you're also a molecular biologist, you're a cellular biologist, and a protein biologist. And I spent about 10 years doing that in academia, working with top research centers in Spain and Germany, and I achieved a professorship in immunology. I thought my life in academia could be a little bit repetitive, to be sure, boring. So I decided to go into industry, and I started working with a big pharma company, Abbott, which then turned into AbbVie. For altogether 15 years, I worked with another big pharma, Becton Dickinson, and technology space. And then in the last 8 years, because I've been living now 10 years in California, in the Bay Area, I was very envious and jealous of my neighbors that were working with technology companies and then became bigger and so on. And then I said, okay, I want to do that too. So that's why I started moving from companies in the hundreds of thousands of people, 20,000 or so on, to small companies. And I've been going down and down to the company in the past 8 years that I'm right now, which has about 25 people. But what I can tell you is that I've never had so much fun, and I was so excited working with a company that is at the forefront of everything that we're talking about. This company has been working with CRISPR-Cas9 for about, I would say, 10 years, or maybe less, 5 years, and we're working in gene therapy. So tremendously exciting. My job and what I've been doing because of my medical background and immunology background has been always in what is called translational medicine, also clinical development and medical affairs. So practically moving research kind of work into moving that through all the steps to get it into an actual medical, either diagnostic or a pharmaceutical product that is going to be used with patients.
Excellent. So I guess if we just unpack what you said a little bit in terms of working with the smaller and smaller companies, because I find my career going a bit the same direction in a lot of ways. And just curious in terms of what has drawn you to that area. Is it the speed of the smaller companies, the entrepreneurial nature, or is it maybe a third aspect might be the large scope of your role and being able to do a lot of things and feel like you're having an impact? Which thing's drawing you to it the most?
Yeah, I always remember what my grandpa told me, obviously many years ago. He said, it's better to be the tail of a lion than the head of a mouse. And I don't think I followed his advice, because I'm now the head of a mouse.
There you go.
I ran the medical team, the chief medical officer of this small company, and I think that what is happening right now is that we are in an environment where there is a lot of disruption. And big companies have already realized that they cannot maintain R&D groups, research and development departments that are able to really cover all the scope of everything happening right now. So the majority of the companies that are moving the needle in terms of all these disruptive technologies are very small companies. And especially when you're in areas, Bay Area, or the Boston area, or San Diego, or different other areas in the world, in different countries around the world, these are the kind of companies that, by the way, interestingly, they are spin-offs of groups in universities and research centers. And this is something that is now much easier to do. Years ago, it was big companies interacting with these centers, but now these centers have their own accelerators or companies, or they are able to create these small companies that then become small biotechs that are very often acquired by mid-sized companies or even directly by large companies. So that's what is happening. I realized that 8 years ago, and I decided to start my new kind of direction there. And that's what I plan to do until something may happen that we get acquired by a big company, which I hope doesn't happen very quickly.
Yeah. I wish you all the luck. So let's explore a little bit more about ASC Therapeutics. What is the primary focus of ASC Therapeutics? And then we'll explore a little bit more kind of the base of that as well.
Yeah, ASC Therapeutics is a company that is based here in the Bay Area. Originally, this company about 12 years ago was created by the current CEO, Ruhong Yang, who decided to create a services company based on his experience with Stanford University. Again, you see this connection with academic centers, and decided to create a services company for the pharmaceutical industry, focused on gene modification, also with that technology that is similar to CRISPR, It's called Target, and also using the CRISPR technology to understand better the way they could help big companies with, again, some of the technological steps that they needed to develop their drugs. In addition, they were working on stem cells. So that's why ASC means applied stem cell. And about 4 years ago, they decided to create a division or a part of the company that would be focusing on actually developing drugs and ensuring that they were using all these technologies. Last year, they decided at some point that they needed to bring someone with experience in clinical development and translational medicine, and that's why I joined the company.
Okay, great. Last year, you made a presentation at Clinical Trials Virtual Nexus, where you compared the development of these disease therapies for hemophilia to landing a man on the moon. And I love a good story. One thing I'm a huge fan of are people that can tie science to other stories, because I think it's the way that we translate things to basic way of thinking, more or less. And so I'd love to hear a little bit more about that as well.
Yeah, I believe in storytelling. And science is extraordinarily complex. And when we talk even about CRISPR, and I'm going to use this analogy with landing in the moon, to explain that the way I explain that even to scientists and researchers, because I thought that sometimes it's good to have very clear concepts so we are able to understand. We have been focusing is hemophilia. Hemophilia is a disease where there is a genetic defect, where there is a missing protein, which is required for ensuring when you have any small wound that it clots perfectly. So there is a cascade of proteins, and they are called factor 1, 2, 3, 4, 5. And if there's some of these proteins are missing, then you have very serious diseases. The one that we have been focusing on is called Hemophilia A, where the protein that is missing is called factor 8. Again, one. So all of them activate the next one, and at the end of the day, you have a blood clot. These patients were, by the way, I was working with some of them because of the HIV situation, where many of these patients, the way they are treated is that they get blood transfusions. And at some point, people still didn't know about HIV, and many patients became infected. So there was a big effort by the entire pharmaceutical industry to create replacement proteins so that these patients would not require blood transfusions. And this is what has been happening over the past 20 years. Oh, excuse me, it's even almost more than that. It's almost 40 years. And right now, these patients are relatively well covered in the sense that there are different types of recombinant proteins that either are replacement for this factor 8 or replacement for other lack of this protein. By the way, I've been talking about factor 8, which is the one that we are focusing on, but there is another disease very similar. It's called hemophilia B, and here the factor that is missing is called factor 9. Okay, is the next one. It's very similar, but I'm not going to go into those details. Now, let me now explain you what is happening and what we are doing at ASC Therapeutics, and not only us, but other companies working in gene therapy and gene editing using technologies that what they are doing is that instead of providing the patient with that protein, with an injection or infusion, they need to get this transfusion of this missing factor 8 regularly. So they need to go to a transfusion center and get these treatments every 2-3 times a week. Otherwise, they would, again, have very serious bleeding.
Doesn't sound like a very pleasant sort of life, having to go constantly and get transfusions.
So when gene therapy started to get into gear, and it started about 10 years ago, hemophilia was one of the first targets. So some of the companies that have been working on hemophilia gene therapy are probably going to have a product out there in the next 2 years or something like that. It was supposed to happen in August this year, but the FDA saw some problems with the product that was about to hit the market, and they delayed the launch of that product, that gene therapy, by about 2 years. So that gave us more time, by the way, to get with our what we call second generation gene therapy. And I won't go into the details, but what we have is a product that works much better than the ones that have been in development over the past 10 years. And that's important to understand. And maybe I can go now a little bit into this landing on the moon analogy to explain to people that are not familiar what is gene therapy, because what I'm going to tell you applies to all types of gene therapy, and even gene editing, and also the concept of CRISPR-Cas9 is included in my storytelling. And I love it because I always remember when I was a child in Spain, and I was just going around in a shopping window. Not everyone had TVs. We had a black and white TV at home, I remember. But for whatever reason, the moment where the Americans were able to land a man on the moon, I was in the street, and I was able to see that through that window, and I was able to see that happening. It was kind of imprinted in my mind. So following that for the past all my life. So it was automatic to try to find this analogy, which I haven't seen anywhere else, but I think is perfect to explain how it works. And I use basically all the elements that are required to get a man in the moon, to ensure that I explain how we get what is called a transgene, which is a synthetic, call it that way, gene, and we put that into an individual, so he's going to start producing the missing protein. So we're going to use a way, I'm going to explain how we are able to make an individual that is not able to generate or produce factor 8 to take care of his or her hemophilia A, how we do that through gene therapy. The first step is that we need a rocket, and the rocket includes a capsule and includes the lunar module, okay? So it doesn't work with the Elon Musk SpaceX stuff. So I have to go back in time and use the Apollo 11. So
we're back to an Apollo 11 rocket now and the lunar lander.
Exactly, because I need a lunar module to be able to explain all this. And we have these three elements, and we are able to produce. There has been a lot of work during many decades, I would say, to be able to produce that. The rocket, as such, is a virus. So what we use is the way we do that. All this is by infecting the individual with a virus that is called AAV or adenovirus, which is totally harmless. But the way we do that in our case is that it has an affinity for the liver, which is the place where we are going to produce this protein, which is the best place to do that. So again, coming back to the analogy, we have the rocket. The rocket is a virus that is manipulated and created in a lab. And the virus includes the capsule, which also has some power. So the rocket is practically the one that takes you out of the Earth's atmosphere, and then you start the journey to the moon. And that part of the journey is practically done through the power of the capsule. And this capsule is what we call, in our biologic terms, a promoter. So we need the capsule, which is the AAV, and inside it there is a promoter that promotes the way we take the actual gene, which is the lunar module. This is the factor 8. So we create the factor 8 and the capsule. Once all three are out of the atmosphere, they enter into the cell. Imagine that we are able to infect the cell with this construct, and we call it a construct. And the moment that it enters the cell, the capsule and the module go into the nucleus of the cell. A cell has basically the nucleus and the cytoplasm, and then the membrane around that.
Mm-hmm.
And we cross the membrane, we go into the nucleus, and in the nucleus, two things can happen with this lunar module. Either it lands on the moon, or it stays circling around the moon.
Okay.
These are the two types of technologies that we call gene therapy and gene editing. The most common one is gene therapy, where this module is going around the moon, and the moon is the nucleus, where is the place where we have, I would say, all the DNA and the genetic information. What we're doing right now at ASC Therapeutics is that we have this lunar module that goes around the genome of the cell and able to produce factor 8 without landing on the moon. Okay, so this is it's called episomal. Doesn't matter, but basically it circles. It's a circular DNA, and it's able, because it has this capsule, this promoter, to produce the protein, and the protein is processed inside the cell, and then is secreted to the circulation, and it works. So it has been already shown by academic research, and also by a number of companies. So it works. So, and not only with this disease, for other diseases also this technology approach. Again, this is what we have been doing, and this is what we call right now, based on what we are doing at ASC Therapeutics, second generation type of treatment, because the way the protein is produced by our lunar module is more efficient than what is right now being shown by other companies. So this is what we call second generation. Now the third generation, which we're working on, is when this module now lands in the moon. Okay? And pay attention to this, because this is exactly what we got this week as the Nobel Prize. And this is the CRISPR-Cas9. What we mean by landing on the moon is that now what we're doing is that we're opening a space there. We're using genetic scissors, and this is a different rocket and capsule and everything that goes in parallel to the one that I just mentioned. And this one makes a hole and puts inside there our lunar module. Our factor 8 is now incorporated into the genome of the individual. Now, this is now also producing the same factor 8, but with a difference. And let me try to explain this concept, and I hope I stop so that you can ask me something.
No, it's fine.
So now, when we use the lunar module going around the moon in a cell, the moment that this cell divides, this lunar module is lost. And that's why what we're doing right now, what everyone is doing right now in the field, is we are only able to treat patients that are 18 years old or older, 18 years or older. And that's because the liver, your liver, my liver, the liver of relatively adult individuals, does not divide. The cells in the liver do not divide so much. It doesn't work with kids. So when they are 6, 10, 14 years old, the liver is replicating and the cells are dividing, and you have to do something different.
So would it decay over time then?
No, it's simply that the cells, there is it's called cellular turnover. So
sure.
The cells simply, and there are new cells coming in.
So it's not like you would have factor 8 for a while and then it would decay over time. It wouldn't sustain, it wouldn't be carried forward in the replication process.
That would happen with kids. So in adults, our liver is already set and there is no so much change. But in kids, there is this change because the liver is growing, like the entire kid. So that's what happens. So the technology where we use module around the moon, which is the genome, doesn't work. So that's why we need CRISPR-Cas9, which inserts the gene inside the cell. So even if the cell now divides, it still maintains the information that we are providing through this gene. This is a way to explain, and we call that gene editing, because again, it's like editing a text. So we are editing the genome, we're putting the actual lunar module inside the moon, on the moon, and not just orbiting around it.
Excellent.
Sorry, I know it was long, but
No, it's a very interesting. It's an interesting story. I watched your video. I'll link it in case anybody wants to watch the original version of this. But it's just a very interesting way to tie the science back to a story that I think a lot of us that are a little older that can. I remember as a kid having a plastic rocket as a kid. One carrying it around. As an American kid that grew up in that time frame, you wound up with a lot of the memorabilia, I think, because it was a very proud moment, I think, for a lot of the nation. But I think the same thing of this, you think about what gene editing could do overall for people, it is amazing. So thank you for the story, and thank you for tying the science to it. I appreciate it.
You're welcome. Yeah, I enjoy telling this story.
All right. So I like to ask 3 questions of everybody that's on the show, and we're at that point in the podcast. So first of all, I'd like to ask you, what inspires you?
So I have two drivers. One is the inner engine that I have, like everyone. And another one, my external perspective. And I cannot describe exactly what is mobilizing me internally. That's probably something that comes with everyone since you're a kid, or that you have any way that you want to grow, you want to learn, you want to see more about life. And in my case, I'm very driven by technology, by biotechnology, by medicine, and learning, and again, understanding the inner workings of everything. So I was a typical kid that got anything for his birthday, and the next day it was totally bits and pieces. I wanted to know everything.
Take it apart. Okay.
My dad and mom, hey, what did you do? What is that? So I want to see how everything works, especially lately. I've been doing something that has nothing to do with what I've been talking about today, and this is understanding the workings of the mind. Okay, so that's a driver. And the other driver, what inspires me, is like I think many of you, what you're doing right now, helping people, understanding everything around us, is trying to help the community, the world, and to have any kind of impact. So in my case, as a doctor, I realized very quickly that my calling was not to do house calls. And it was not going one patient by one, although I've done that too. But I wanted to really help many people simultaneously. And that was through my work in academia, in science, and also in industry. And that's also a driver. And something that also drives me now, and you mentioned that you, at some point, maybe I could bring that up, is also helping people go through this very difficult situation that we are right now in our world that is so disrupted and so difficult, with so much anxiety and so on. So I went also through a very difficult period in my personal life and professional life, mostly personal, in fact, also professional. And I decided to start helping people deal with anxiety. And I wrote a book which is called Mindful Framing, Transform Your Anxiety into Vital Energy. The book is doing very well. Now, I wrote it 2.5 years ago, but I decided when the COVID epidemic started to put my Kindle book for free. So, and I'm going to keep it indefinitely. It has, as you can imagine, many reviews and downloads and everything. So I'm very happy about that. And that's something that also motivates me and inspires me.
So I'll have to include in the show notes then as well a link to that. That would be a great thing for people to be able to pick up and have a look at your book as well. So thank you.
Thank you. It's on Amazon, so it's very easy to download.
And what concerns you?
So I think that what concerns me also is related to what I just mentioned a moment ago, is the excess of anxiety and the way the world is turning is too much for all of us. I think that our brains, our minds, our bodies are not really ready for what is coming so quickly and everything at the same time. And this is happening everywhere. I was just reading the news this morning of the chaotic situation in Madrid, Spain, which is becoming one of the hottest spots for COVID right now and so on the struggles that they're going and interacting with my family and friends. So that's one example, obviously. But it's not only that. In the past few years, the information overload, the accelerated disruption that is going on is really concerning. So I hope that everyone is going to start getting a little bit more settled down. I hope that we're all going to be able to do that. And always look from these two perspectives. So there is the personal perspective, how each individual is going to be dealing with that. And I don't think that this is something happening. I don't think that we were trained or we were taught at school or anywhere how to deal with our mind, with our thoughts, with everything that happens around us, and also being more open, more community focused, have more gratitude, more compassion for others, and think about the entire humanity as we are all on the same boat. Unfortunately, now there is more division than getting all together. So I stop here. There is much to be concerned right now.
Yeah, for sure. You touched on quite a few topics, and between just being able to be respectful of people's kind of position is one part, but also having the ability to just understand and respect what happens with all of us in this isolation period that we're in is not pleasant in general, and we need this personal connection. And this is one of my forms of outreach is the podcast. So, so I appreciate all of you for that as well. Last question. So what excites you?
So I think it's related to what I just mentioned. First, what excites me is from an individual, from a very perspective, is the potential of the mind. And I have developed this practice, which is a kind of adaptation of the ancient cultures of meditation to our current situation and world, and it's called mindful framing, because what you do is that basically you create a framework in your mind. You use also breathing techniques and things like that, but you don't empty your mind. It's not about just trying to observe your thoughts and using these kind of approaches or listening or being distracted by someone speaking like Headspace or Calm or all these apps. No, this is an actual exercise in your mind where you develop your own movie in some way, and you repeat it, and you create your own way of seeing the world. So I'm very excited about that. So I'm developing that. I'm now thinking on the second edition of my book, which may still take a couple of years. I have many blogs. I'm a blogger. It's related. You can find it in related to the book, and the link that you're going to send. The link I suggest that you send to everyone is called mindfv.com or mindfulbook.com. And I have many aspects about how our mind and how it relates to the neurotransmitters and hormones and things like that, and how everything works together. And the other aspect is helping others, revolutionary technologies to change the way we see medicine. And I can tell you, medicine is changing in many ways, not only from a biotechnology perspective, but also the way it's delivered. So the way you are going to start seeing your doctor. Now my GPs, I speak on the phone with them, or I have video conferences like now. So all this is changing. So, and I think that physicians and physician scientists like me can help many people also explain a little bit all these changes, like the analogy I was using a moment ago, to ensure that people can adapt to this. I call it already medicine 2.0. It's going to be completely different to the way we have it. And I hope that something happens, that at some point I'm going to be putting together this individual perspective on working on the mind and medicine, and we're going to start using a little bit of both. Actual conventional medicine, but also some ancient wisdom that can help us also be more calm and take life a little bit more easy.
That's again another. I always appreciate the answers that people give to these three questions, because I have no idea which direction it's going to go. I always completely appreciate the perspectives that are shared, and so thank you for those. And so, Dr. Oscar Segurado, I would like to thank you for being on the podcast today, and thanks so much for being here.
Thank you so much for having me. It has been a real pleasure. Great questions, great conversation.
Thank you for listening to Life Science Success. For complete details about this podcast, including show notes, how to get in touch with guests, and more episodes, please visit www.lifesciencesuccess.com. If there's someone you'd like for us to invite to the show as a guest, please let me know by sending me a message at the podcast website. Please click subscribe on your favorite podcast app, share the podcast, or tell a friend about it, and last but not least, rate the podcast. Thank you again.